let's have a look at the switch port VLAN configuration settings on a Meraki switch. We can start reviewing our network connections by navigating to network-wide, followed by topology. We can verify our switch port connectivity for our uplink ports between our downstream and upstream switches here. For example, my IDF switch is connected to my MDF switch. I can hover over that connection and I can see that port 8 is the uplink on the IDF connected to port 23 on the MDF switch. Also, the connection between the lobby switch and the MDF, if I hover over that connection, I can see port 8 is the uplink port on the lobby switch connected to port 13 on the MDF switch. When we're ready to continue with our configuration, we want to access our switch port VLAN configuration page. I will navigate to switch, followed by switch ports. Here I can use the search box at the top and I can filter by a custom tag that I have created, and that tag is SW Connect. This will help me to easily identify the switch uplink ports on the lobby, IDF, and conference switches. Also, the CDP LDP column provides automatic discovery of connected devices and their capabilities. We can easily verify that we're about to configure the correct ports. I will check the boxes next to each of the ports that needs to be updated. In our scenario, we are updating the uplink ports from our 3 smaller Meraki switches. The ability to search, filter, and configure our switch ports across these multiple Meraki switches is what we actually refer to as virtual stacking. With these 3 uplink ports from our Meraki switches selected, I will now select Edit. The Meraki dashboard reminds me that I'm editing uplink connections. A mistake here could prevent our Meraki switch from having dashboard reachability. The default port type is set to trunk, which will allow the selected ports to accept and pass 802.1q tag traffic. Also, these ports are set to use the native VLAN of 1, which will take all untagged traffic received on these ports and place them on this specified VLAN. Also, any VLAN 1 traffic that's being sent on this port will be sent untagged. Now, I'm going to modify the VLANs allowed and limit the specific VLANs that will be able to traverse this trunk link. I will limit it to only VLANs 1, 10, 20, 30, 40, and 50. I will complete our trunk configuration settings for these multiple ports by clicking Update. With the 3 uplink ports configured appropriately for trunking, I will make a shift to verify the voice and data VLAN configurations. To configure the appropriate ports connected to our PCs and VoIP phones, I will clear the filter in our search box and now search for a custom tag of tag PH Connect. This will easily help me identify those ports on the lobby, conference, IDF, and MDF switches. Only a small number of VoIP devices have been installed, which we can see using the CDP LDP column. I have 5 switch ports identified for VLAN configuration that will be connecting to VoIP devices and PC connections off of the VoIP device. I will check the boxes next to each port, and then I'll be able to select Edit. Again, the default VLAN configuration is commonly set to trunk, but with these 5 ports, there are multiple values configured. For our purpose of deploying our phones and PCs, I'm going to modify these 5 switch ports to all operate as access ports, and I will specify the data VLAN value to be 20. This will be for all traffic received on these selected ports without a VLAN tag. I will enter the voice VLAN value of 30 to allow CDP and LDP capable voice devices to be able to use this specified voice VLAN. I will click Update to update these 5 selected switch ports across our Meraki switches. On our switch ports page with our filter of tag PH_connect still applied, I can verify the switch port configurations across these 4 Meraki switches. This simplified yet powerful process of dashboard configuration allows scaling VLAN deployments verification, and even troubleshooting by using our dashboard.